This meeting is being recorded.
We've seen in previous problems from chapter 3 ways to compare compounds to determine the most acidic compound, and even how to determine which proton is the most acidic in a compound. And we looked at which atom a proton was connected to. So was it more electronegative if they were in the same row, or if they were in the same group? We looked at size of atom. Then we looked at if there are resonance structures possible to stabilize conjugate bases that would determine which proton was most acidic. Then we looked at inductive effects recently in some problems as far as the electron withdrawing groups, how close they were, or how numerous they were to acidic protons. And now we're going to look at the O in areo. We're going to compare protons to determine the most acidic protons in these structures below by determining what hybridized orbital these protons are on. So let's take a look at this first structure here. We'll call structure 1. And I put some dots here as to carbon atoms and then drew some protons and then told you what the hybridization of the carbon's orbitals would be. So we see up top here, these hydrogens, these protons would be sp3 hybridized carbon attached to sp3 hybridized carbons. Then we have, again, below, 3 more protons. Really, we know there would be 9 down here, all equivalent. That would be sp3 hybridized. Then to the right, we have these sp2 hybridized hydrogens, protons. And then we have this one over here on the end of this triple bond, that would be sp hybridized. If you recall, the sp hybridized orbitals are the most would produce the most stable conjugate base. So when this is deprotonated, that lone pair is better stabilized with an sp hybridized orbital. So this would be our most acidic proton over here. Something similar with compound 2. Again, we see these, there would be 3 sp3 hybridized hydrogens here, 3 over here as well on that carbon, and then another 3 sp3 hybridized bonds down here. And last but not least, we have our most acidic proton will be the sp hybridized carbon proton here. So that would be our most acidic proton. In our last structure, we see lots of sp3 hybridized hydrogens, sp3 hybridization over here as well. And we see in the middle of the compound 2 equivalent sp2 hybridized protons. So both of these would be equivalent, and therefore either one we could say is the most equivalent or most acidic proton in structure 3 here.